Hello everyone, welcome to the lecture number 6. Today we will discuss that how much time it will take to empty a tank or how much time it will take for a liquid level to fall from certain height to another height. Let's start the topic. See, this is a container filled with liquid of density rho. Area of the cross section of the container is capital A and there is a hole at the bottom through which liquid is coming out, and due to that tank is getting emptied, and the area of cross section of the hole or the orifice is small a. See, as liquid is coming out through the hole, the liquid level in the container is falling, and due to the falling height of the container, the velocity of the efflux is also reducing. So the volume flow rate out through the orifice, that is also decreasing. So this is a variable velocity of efflux problem. How? At any instant I have to consider that, okay, suppose the liquid level height is suppose y from the orifice. From the orifice, the height of the liquid at any point of time is y. If the liquid level height is y, then what is going to be the velocity of the efflux through the hole? It is root over of 2g into y. So how much volume will come out of the nozzle per second per unit time? Liquid coming out through the hole per unit time will be velocity into the area, that is the volume flow rate of the liquid. So volume flow rate out at the instant when the height of the liquid level from the orifice or from the nozzle is y, velocity at that instant, that is root over of 2gy into the area of the orifice, that is the volume flow rate out. Now suppose due to this volume flow rate out, the liquid level in this container that will get reduced by small amount. Let's say the liquid level in the container is reduced by small amount dy in time dt. In time dt. So in dt time, how much volume will go out from the container is volume flow rate into the time. So we will write that root 2gy into a into dt. So in dt time, volume of this amount will come out from this container, and due to that the liquid level in the container is reduced by dy amount. Now that means this volume will be equal to the volume of this dy height column. Area of the container into the height of the liquid column reduced, that is going to be the volume come out of the hole. So we can write that as this height is reducing, you can write minus, that is equal to root over of 2gy into area of the nozzle into dt. So that is our equation. So we'll write that dt is a by a dy by root 2gy, and minus will come here. So this is constant for a particular container and for a particular hole. This term is constant, and this denominator term root 2g also is constant. So we'll write that minus a by small a root over of 2g dy by root y, that is dt, small time dt. So let's say from 0 to time t, the height of the column is reduced from hi to h final. Then we can integrate this term and we can find out how much time it will take for the liquid column level to go from height h1 to height final hf. So let us do the integration. We'll do this here. Minus a by small a root 2g. Integration is going to be 2 root y, and we'll put the limits. Then minus a by a root over of 2g to root over of HF minus HI. So that is time t. So we can write that A by A root over of 2G into 2 root over of HI minus root over of HF. So that is the time taken for a liquid column to come from H initial height of this to suppose some height of HF. This much time it will take. Now if I have to find out the time taken to empty the tank, the final height will be 0. And initial height will, let's say initial height is capital H. We'll put that. To find out time taken to empty a tank. So here it is A by A root over of 2 by G will write, and H initial will be root over of H minus final is 0. So see how much time it is taking. A by A root over of 2H by G. So that is the amount of time it is going to take to empty a tank which had the initial height of capital H, and the area of cross section is given as capital A and small a respectively. So I hope you understood. Now let's discuss a problem about the same topic. A uniform cylindrical container is filled with liquid up to height capital H. In 10 seconds, liquid height is reduced to H by 2. How much more time it will take to empty the tank? So what do we know? The time formula we have just derived. Time is A by small a, that is the area of the container and the area of the nozzle, into root over of 2 by G, and if the liquid column height is coming from HI to HF in that time, then the formula will be this one. Capital A by small a into root over of 2 by G into root over of HI minus root over of HF. Now it is told that in 10 seconds liquid height is reduced to H by 2 from the initial height capital H. So we'll write that T1 is equal to 10 seconds, that is equal to A by A root over of 2 by G. Initial height was H and the final height is becoming H by 2 in 10 seconds. So that means in how much time the liquid column height will become 0 from the initial height of root over H by 2 right now. So we'll write that, let's say the time will take T2, that is equal to A by A into root over of 2 by G, and in the second case the final height is becoming 0 and the initial height is root over of H by 2. The final height is becoming 0, so we can write that. Now this is our equation number 1 and this is our equation number 2. We can divide equation number 1 by equation number 2. Then what will we get? 10 by T2. This term is common, so it will get cancelled. So root over of H minus root over of H by 2 by root over of H by 2. So T2 is root over of H by 2 by root over of H minus root over of H by 2 into 10. So this term H will get cancelled everywhere. So it will be 1 by root over of 2 minus 1 into 10. So that is approximately equal to 2.4 into 10. So that will be 24 seconds. Now try to fill the problem. So initial height was H, the half tank is getting emptied in 10 seconds, but the latter half is getting emptied in 24 seconds. See how much higher time it is taking for the tank to get emptied. So why is that? Because initially the liquid column height is very high. So slowly when the height is reduced, the rate of fluid coming out is also becoming less and less. The more the liquid will come out, the lesser will the efflux velocity. So latter half is taking more time to get emptied. I hope you understood this problem. Thank you so much for watching.